go over the quiz 1.4, whatever, and all I need is this graph paper so that I can show you. When I previewed the quiz like this morning, the other day, it looked kind of weird. Some things were like, I was looking at some of y'all's graphs for the answers, and I was like, something's not right. And so for some reason, some of my negatives were not showing up. So as long as you guys are doing it, we're okay on this one. So I'll take this one as a hit for me. But I want to make sure that you know how to do it because some of the ones that I was looking at were not that great. Don't take that wrong. Domain graphing is not easy. I want to go over the quiz because when we do piecewise, we're doing the same thing. Okay. So I want to give you a refresher. We've had 3 days off to make sure that you know what you're doing. So we're going to go over these 6 problems and then we're going to do the piecewise. Graphing piecewise is exactly the same as this. Okay. Except for you have 2 or 3 different graphs that you're graphing, but it's the same thing. Okay. And then evaluating piecewise is super easy. Got it? So it'll start off hard and then the last part will be super easy. Your quiz is both. You have to graph and you have to evaluate. Okay. For those of you sitting in here, I printed it off for you. So I will give you your quiz when it's time, like after I finish the Zoom. So you guys all have paper. You just have to upload it. Everybody else, if you want to print it, that is perfectly fine and upload it. If you if you don't have a printer and you can't print these, guys, you're either going to have to start picking them up for me or you're going to have to figure out a way to graph it where I can read it. You can't just graph little lines and expect me to just count it right. I have to have an x-axis, a y-axis, and it has to look correct. If I can't read it, I can't grade it, okay? I don't mind you doing it by hand. I told you a required material was graph paper, did I not? Said you were going to have it for at least this first unit. So you guys are going to have to figure it out. That means if you have to buy some graph paper, buy some graph paper, print it. I don't care. But if it's by hand, it has to look neat enough for me to read. Okay. Otherwise, I can't grade it. So we're going to start the first one that you guys had, and I'm going to use quite a few. Oh, Lord, please be on time. I'm going to start with the first one. And again, I'm going to use like 4 different pieces of graph paper. So the first one that you had was x squared. And then I had this semicolon, and that just means your graph is this. Hey, let's bound it here. So it's just a separator. That's all it is. It's nothing to do with anything. It was x is greater than -2. I think the next one, you couldn't see the negative on the x squared. Some of you could. I couldn't this morning. I don't know what it is with what platform. I don't know. So just in case, I want to make sure I went over it. So if you're doing it on your graph paper, here's my X and Y axis. If you have by hand, just label it X and Y so that I know where it's at, okay? That's all I'm asking you to do. Nothing crazy. You don't have to like make it darker or anything like that. Just let me know where it's at. So then in our calculators, remember we're bounding at -2. So I draw my line at -2. This boundary also tells me that the point is open and we're graphing to the right. Why is it open? Because we don't have an equal mark. Why is it to the right? Because it points, if I make like an arrow, guys, it points to the right. Does that make sense? So we're graphing it on the right side. So we should not graph over here at all. There should be nothing on that side. Okay, so boundary point over. So when I put it in my calculator, some of you are doing that and that is perfectly fine. Some of you are plugging in the points, also fine. I'm going to look for my boundary point, -2. So I'm at -7, -2, 4. So here's -2, 1, 2, 3, 4, and we said it was open. Don't graph anything on the left. Now I just look at points on the right. So what would be on the right? -1, 0. So I'm going to go down in my chart. -1, 1, 0, 0, 1, 1. And remember what I told you, once you find that vertex, you're good to go to graph. I would like 3 points, 3 perfect points. But on this one, you actually had to graph 4. And if you want to keep going further, remember that it's very symmetric. And it would look like this, okay? So open on the boundary and then make sure you graph to the right. Everything else is normal. So the only thing you don't do is same as we graphed in the very first set of notes, except for we stop it right here, okay? That's it. All right, so there's number 1. And you guys can go back and watch these, and that's fine. Don't forget that. They're all recorded. Here's number 2. This is the one when I tried to open it this morning that you couldn't see that negative, or on a couple other ones you couldn't see a negative. Okay. Now at home I could see it. So if I'm not seeing it, then there may be some of you that are not seeing it. It's okay. It's just the format that's used. All right. So we're going to do the same thing. Here's your XY axis. We have a boundary at 1. So we graph it. We're going to do the same thing today. This tells us that it's closed because it's equal and it's pointing to the right. I don't graph over here at all. And you guys can do that if you need to help you out. Okay, not a big deal to me at all. All right. So then we're going to put our function in, but this time it is negative x squared. We're looking at our boundary point +1, -1, +1, -1, and it said it's closed. Again, I over exaggerate my boundary point so that you guys can see it. Okay, that's the only reason. Then we graph to the right, so that means I graph 2, -4, 3, -9, and you guys see that it's just going to keep going down. So it looks like this. Our vertex would have been at 0, 0, but we don't graph over there. All right, that's all you had to do. 3 points and we're done. Got it? If you weren't sure what it looked like, hit graph. Sorry, mine's on stats graph. Hold on. Sorry. You can see exactly what it looks like. So that way you know you got it right. Check your answer. Always check your answers. Okay. So there's the second one. The third one was an exponential. And we should do x is greater than or equal to -2. Just to forewarn you, we're also going to do domain and range today too. So today might last a little bit longer than normal. All right, because I'm going over this quiz and we're doing like 3 different things. All right. So we're going to change it to the x. I'm going to go to my table. My boundary is at -2. It says my boundary is closed. And we graph to the right. So nothing over here. All right. My boundary is at -2. So -2 is 0.25 or 1/4. -2, 1/4, and it's closed. Again, I make such a big point that it's going to take up a lot of space. So it's perfect as long as it doesn't touch the x-axis. And mine kind of touches a little bit because I made it too fat, but I get it. Okay, so don't stress out about that. Then we go to the right. So -1.5. So it'd be like right there. 0, 1, 1, 2, 2, 4 is good enough. It should look like this. That's it. Okay, so don't stress too much about what they look like. If you need to, like I said, graph and check it out. Does it look the same? Yes, it does. That shape is the same as mine. All right. Use that calculator because remember, you can always use it on the final exam. The only thing I'm asking you not to do is use Desmos and take a screenshot of this graph. That's it. I want you to be able to do it by hand. Okay. Number 4, 2 to the x minus 1. But this one is between -1 and 3. -1 and 3. So here's my graph. I actually have 2 boundaries. One at -1. One at 3. The one at -1 is closed. I'm sorry, is open because it's not equal to. And the other one is closed. This means we graph between. So we don't do anything over here at all. Okay, just in the middle. All I'm going to do is put it in 2 to the x. We're going to do that -1. Look at our table at -1. Our coordinate is -0.5. And it is open. Again, I over exaggerate it. It's perfectly fine. We go to the right 0, 0, 1, 1, 2, 3. And then on our boundary 3, it is closed at 7. 1, 2, 3, 4, 5, 6, 7. Connect the dots, don't go any further. That's it. Okay, don't make it more complicated than what it is. 2 more of these and then we'll start our notes. 2 more of these. All right, number 5 was absolute value of x plus 4 minus 2, negative 1 less than x less than or equal to 5. What kind of function is this? Anybody, what kind of function? If we don't know, we're going to fail our test. Talk to me. What kind of function is this? Absolute value. It is absolute value because it has an absolute value bar. So what's the translation here? We're doing good with absolute value, exponential, quadratic, labeling them. We're doing a great job on our quiz. Translations, we're about half and half, okay? So what's the translation on this one? What's your vertex point? Guys, I know you know it, but don't make me sit here and talk to myself all day. And I'm not talking specifically about you guys, but there's like 50 people on Zoom that hadn't said a word today. So Zoomers, tell me what my vertex point is. Aaron, tell me what my vertex point is.
Is it -4, -2?
Yes, y'all are wasting, y'all know this. I know you know this. So you're kind of wasting our time to get to our homework when you don't answer. So please answer. If you're wrong, who cares? Nobody knows. Okay. I know, you know, we're good. That's it. All right. So -4, -2. What does that tell us? Another Zoomer, tell me what that tells us. Clay, tell me what that tells us. Tell me what that tells me.
I don't know.
Mm-hmm. One of them is a left-right movement. One of them is an up-down movement. You can tell me one of them. Clay, you're getting them right on your quiz. That's why I called on you. Just
What was the question again?
make sure you're paying attention. What movement is it? What translation? Up, down, left, right, and how far?
Be down. Be down 4, and then you're right 2.
Okay, so you mixed them up. All right. So that's what I'm seeing. You can mute now. That's what I'm seeing on a lot of you guys is that you're mixing them up. All right. Remember, if it's with X, which way does the X axis run? Left to right. So if it's X, this has got to be your left right movement. Remember, we pull it outside. That's the second mistake that I'm seeing. You have to change that sign. So on your quizzes, I'm trying to tell you, go back and check your comments because I don't just count it right or wrong. I tell you something is wrong, okay? And I tell you what you did wrong. Now, after the first time I'm telling you, I might go back and say reflection. I might say left right movement. Something is wrong, okay? So on this one, because it's with the X, it's a left right. When we pull it out, it's a negative. On the negative X axis, which way did we go to graph negative? Left. Guys, think about it this way. The reason I've been telling you to pull the vertex out is if I graph this, and I'm not trying to do that right now, but if I graph it, you guys always start at 0, 0. What are the directions I go to graph this? I go left 4, down 2. That's your translation. How did you move from 0, 0? I went left 4 and down 2 to make that first point. Okay. The other thing that you're missing is your reflections. Okay. If it's on the front, so if it had been a negative absolute value, that's changing y is a reflect x. Okay. So on the front is a reflect x. If it's right beside the x, that's a reflect y. So you're looking for negatives. Don't care about these negatives. You care about the negative in front and a negative with x. Okay. So watch those. Back to what we're doing. We have a -1 and a 5. 1, 2, 3, 4, 5. I didn't graph very good. Clay, thank you for answering that. I really appreciate it. You just mix them up a little bit, okay? So now, on -1, it's open because it's not equal to. On +5, it's closed. And remember, we only graph between. Okay. We're going to put our function in. To do absolute value, go to math and num, and you get your absolute value bars. X plus 4, you hit the over key to get outside of it, and -2. We're going to look at our table, and remember, we want to start at -1. Our coordinate is -1, 1, and it is open. We have 0, 2, 1, 3, 2, 4, 3, 5, 4, 6, and 5, 7. When we graph it, you should see that it is the right side of that absolute value. So your vertex is way over here. Remember, your vertex is at that -4, -2. So we should see something that looks like that. Okay, so if you get a little bit confused, just hit graph and see if you did it right. All right. Number 6, I'm going to ask you the same questions that I just asked you, so be ready. We have a -x plus 2 squared -3, and we want it when x is greater than or equal to -3. Quickly, what kind of function is this? Guys, come on. What kind of function is this? Absolute value, exponential, linear, quadratic? What is it? Anna, what kind of function is this?
Quadratic.
What are my translations? Jared,
I'm not
what are my translations?
-2, -3.
That's not Jared.
Oh, I thought you said my name.
Oh, no. That's your vertex point, -2, -3. Jared, what is your movement? How do I graph -2, -3? What direction?
Left 2, down 3.
Perfect. Those are your translations. That's it, guys. Do I have a reflection on this? Yes. What reflection do I have if it's in the front? It's opposite of what you think. Remember, if the negative is with x, that's a y. If it's on the front, it's an x. So this one, just a reminder, is a reflect over, good gracious, over the x-axis. If it's on the x, like this, -x, it's a y-axis. So it's opposite of what you think, okay? So with the x is a y, on the front is an x. All right, so this one is on the front, so it reflects x. Think about your U shape. When I have a -x² U shape, -(x², what does it do to that function? Flips it over the x-axis. Okay, so this one's going to be an upside down U or an M shape. All right, so here's your y and your x. We're bound by -3. We're going to put this function in. By the way, great job on that. Thank you for answering. We're going to look at our table. And we're only looking at -3 for a minute. So -3, -4. Is it open or closed? Open or closed? Closed. Why is it closed? Because it has an equal mark. So -3, -4, that's my boundary closed. It says greater than, so I'm not graphing over here. -2, -3, -1, -4. You guys can see that this was quadratic. It was going to be in shape. That's my vertex. I don't have to graph anymore. This is what it's gonna look like. The only way I would have to graph more points is if it was in between. I want you to graph all the points in between. And that's it. So that's what your quiz should have looked like. Now, everybody that's done the quiz, I'll go back in and give you credit for that. Even if I've graded it, I'll go back and regrade it because I didn't realize some of those are not showing up correctly. This morning they weren't. I don't know. Canvas updated, so it may be something with the update that it didn't pull through. Okay. All right. Grab your note. And we're going to work on these piecewise. So if you look, it looks exactly the same. There's nothing any different, except for we have two functions at the same time. So sometimes you'll get those two functions and you'll see that they both have the same boundary line. Did I see that? So we're going to do the same thing. We're going to graph our boundary line at -2. And then those inequalities tell you the exact same thing, okay? So this inequality right here tells you less than is to the left. And then because it's not equal, it's going to be open. So the function that's beside it, if you look at it this way, it's just one color. This function goes with this boundary. Everybody see that? So on the left, we're going to graph x plus 5. That's the only thing that can go on the left. That's exactly what we did on Friday. That's exactly what we just did together. All right. Now this time you're going to have something on the other side and it's going to come in the form of another function. So this one, because it's greater than, tells you it's on the right. And because it's equal to, it tells you that it's closed. So -4 will be graphed on the right. And the point that happens on the boundary will be closed. Guys, you're literally going to do it the same way. So all we do is just like we did on our quiz, we're going to ignore this and we're going to ignore this side. We don't want anything on that side at all. I'll make it a little better for you. Okay, we don't want any of that at all. We just want this little graph and this part on it. Again, use your calculator, guys. Go into y equals, type in your x plus 5, and look at your table. My boundary point was at -2. My coordinate is -2, 3. And we say it's open. -2, 1, 2, 3 is open. We want to graph on the left, so we have to do everything less than that. So don't go any further than this right here. So we're going to go -2 to -3, 2 to -2, 3. I'm sorry, a negative, got to go up. -4, 1. And if you guys see the pattern, you can see that it's going all the way across. Again, I only need the 3 points, but make sure that you make that arrow. Okay, make sure that you make the arrow. So that's exactly what we did on Friday, right? That's exactly what we did at the very beginning. The only difference is now we have to graph on the other side as well. So what we're going to do is ignore that function that we just had and ignore the side that we just graphed and graph the other side. So in my calculator, I can put in that -4 and I can look at my table. The boundary line is at -2, so -2, -4, and it said it was closed. And then we go everything to the right. So -1, -4. If you guys look, it's all -4, and it makes a horizontal line. That's it. Okay, so treat them as two different domain restricted functions. So the same exact thing we did on Friday, we're just putting two graphs on one quadrant. All right, so now let's talk about domain and range. Domain, how far do we go to the left? Because you have to answer, we're not moving anywhere. You're wasting your homework time. Negative infinity, thank you. Remember, it's in parentheses because it's never counted. We go to the right and we kind of stop because we see a hole, but what else do we see? Closed fills in the hole, right? So these cancel each other out, so there's no stopping. We're just going to keep going. And what do you see on the other side? Infinity. You will have these on your test, so you need to make sure that you know how to do these. Then we're going to do our range. Be careful about this. This is why I say stretch it all the way across your graph, because what's the lowest that this graph goes? If I keep stretching this across my graph, what's the lowest this graph goes? Negative infinity. As we go up, we keep going up. We don't see any holes, nothing crazy. There's stuff touching my paper. Then I get to this hole. Where is it at? What's the highest point it goes to? 3. Is it included or not? Very good. Is it bracket or parentheses?
Bracket.
Parentheses. Why is it parentheses and not bracket? It's an open circle. So be aware of that. And you will get counted up on your test for brackets versus open parentheses, okay? So be ready for that. And before we take our test, we'll do a review. It'll look just like the test. Got it? Don't freak out. It's going to look exactly the same. All right, so we're going to do this again. Graphing, domain, and range. This is the hard part. All right, where's my boundary at on this one? It's at 1, so I'm going to graph 1. This inequality, the two things it tells us, it's pointing to the left, and it is not equal, so it has to be open. Again, pointing to the left. So that means this function is on the left. If you want to go ahead and graph that one and then move to the next, that's fine. I just like to do them together and then graph them separately. If you look at the next one, this one is pointing to the right, and it's equal to, so it's closed. So this function goes on the right. So again, let's ignore the bottom function. And let's ignore the right side. We don't care about that right now. I'm going to put this function in my calculator. Y equals 2x plus 1. Look at my table. My boundary line is at positive 1. My boundary point is 1, 3, and it's open. Now I need to graph everything to the left. So 0, 1, negative 1, negative 1. If you can see the pattern, it's down 2 over 1. And again, I like to graph them all the way across my paper so that I don't get screwed up with my domain and range. Okay. So there's that one. We're going to look at the bottom one now. We're going to graph it on the right side. So I'm going to use my calculator again. Negative 2x plus 3. And I'm going to go to my table. The boundary point is at 1. And it's 1, 1. And it's closed. Okay, boundary point is closed. And we're going to graph it on the right. 1, 1. 2, negative 1. 3, negative 3. And then so on and so forth. You can see the pattern. And I'm going to graph it all the way down. So then your piecewise function looks like that. All right. Our domain, how far to the left does it go? Negative infinity, because it has an arrow. As we keep moving, I see an open point, but I also see a closed point touching my Post-it note, so they cancel each other out. So we don't have any gaps or holes or anything like that. We keep moving, and we see an arrow on the other side, which means it goes to infinity. Okay, so again, open and closed cancels itself out. Range, how low does it go? Negative infinity. It goes up. I don't see any holes or anything like that. Still touching some Post-it notes. And then I get to the top point and it is opened at perfect. And again, parenthesis because it's an open hole. So look at this domain and range and look at the other domain and range. What do you notice? They're the same. Do the graphs look the same? No. So they can have the same domain and range and the graphs can look all kinds of jacked up, right? Okay, so just keep working with that Post-it note or whatever. If you need that while you're taking your test, do that. But you have got to know how to find domain and range. All right, check this next one. Where's my boundary at on this one? +2. The first one is less than. So it's on the left. And again, if you don't know the name of the signs, it's okay. Where does it point? It points to the left. And it is closed because it's an equal to. This one points to the right. And it is open because it is not equal to. So our first function is on the left. Our second is on the right. Graph your first function. Remember, we can use our calculator to find our points. That is perfectly fine. -2x -4. On the boundary, it says it's closed. My boundary is at 2. So 2, -8 is closed. And then we graph to the left. That's up in your chart. 1, -6. 0, -4. Again, you can see the pattern up 2/1. And I know it takes a couple more seconds, but for domain and range sake, I like to do it all the way across the graph. Again, if you're not sure you graphed it right, hit graph and see if it looks like that. It sure does. Okay, so go ahead and check it if you need to. All right, the second one is 4x - 9. So I'm going to go back into y equals. Put in my 4x - 9. The boundary is at 2. So 2, -1, and we said that that one was open. We're going to graph to the right, so that means bigger values. 3, 3, 4, 7. And if you can see, that's up 4 and over 1, and I really can't get another one on there. And then connect your dots. There's your piecewise function. All right, so your domain. On the left, I see an arrow. So negative infinity. As I go to the right, I see an open circle, but there's a closed circle touching my Post-it note too, so I just ignore it and keep moving all the way to the left. Now, the range is a little different. What's the lowest point it goes? Look at it one more time. -8. That's okay. That's okay. It's a closed point. So I'm going to bracket it, -8. As I move up, I see a hole, but I'm touching another graph, so it cancels it out. And then as I go up, what do I see? Where does it go to? Positive infinity. And again, parentheses because infinities don't count. All right, so look at the next one. What do you notice about the next one? Yeah, so the next one actually has 3 functions, and it's the same exact way, okay? So if it has 3 functions, it's gonna have 2 boundary lines. What do you think my 2 boundary lines are? -2 and 4. So here's my boundary lines at -2 and 4. It's the same thing we've been doing. We just have 3 functions this time. So the first one points to the left, and it is equal to, so it's closed. So on the left, I'm doing x minus 1. On this one, x is where? It's in between -2 and 4, right? So this is going to go in the middle. On -2, it's going to be open because it's equal to, just like we did on our quiz. I mean, not equal to. And then on 4, it's going to be closed because it is equal to. So our 2x minus 1 is going to go in the middle. And again, it looks complicated, but we did that one on our quiz where it was in the middle. It's the same exact thing. We're going to split it up. Then the last one is pointing to the right, and it is not equal, so it is open. So -3x plus 8 is going to go on this side. And again, I just write them on the top to remind you, you won't see that. So let's start with our first function. I'm just going to put it in my calculator. Like I told you, use it as much as you want to. Just make sure that your graphs are by hand. So x minus 1. On the boundary of -2, it is closed. So -2, 1, 2, 3, -3 is closed. And we go everything smaller. -3, -4, -5, -6. If you guys can see the pattern, it looks like this. Okay. Sorry, you can't see it. Make it a little bit bigger for you. Then we're going to move to the middle. So you're only looking at the middle. We don't care about this side. And we've already graphed on this side. So we're only looking at the middle. In my calculator, 2x minus 1. On -2, we put that it's open. So -2, -5, it's open. Sorry, I'm gonna move some Post-it right here. We're going to keep going. -1, -3. 0, -1. Hopefully you see the pattern. 1, 1. So it's up 2/1. When I get to this other boundary on 4, make sure it's closed. And then that's our graph. Right. The 3 graphs are where the domain and range may get complicated. Everything else is exactly the same. Last thing we want to do is graph on the right. So we're going to put it in our calculator. -3x plus 8. We're going to look on our boundary of 4. And we said that it was open at 4, 1, 2, 3, -4. We're going to open it. Everything bigger. 5, -7. And then 6, -10. So it looks like this. And then when we finish, it's a crazy graph. Again, I try to give you lots of visuals and things that you can do. If you guys here need post-it notes, just yell at me if you want to use whatever, I don't care. Okay, so we're going to start with domain. How low does this graph go? Negative infinity. As we go up, I'm going to stop at holes. I see a hole there, but it's still touching graph, so it's not a big deal. We're just going to skip over that. Same thing here. I have a hole, but if you look on this side, I have a dot, so we're still okay. We're going to keep moving until we get up to what? 7. And is it open or closed? It's a closed dot, so it's a bracket. Very good. All right, your range. Your range. How far to the left does it go? I mean, sorry. I just did range with you. Let's do domain this time. How far to the left? Y'all yell at me when I do that. If there's an arrow, how far to the left? Negative infinity. Very good. I'm going to move over. I see a hole, but there's a closed point, so I'm going to just keep going. I see a hole, but there's a closed point, so I'm going to just keep going. How far to the right does it go?
Positive infinity.
Positive infinity. Perfect. Sorry, I don't know why I did the range first. I apologize. All right. Any questions on those? All right. So I'm going to skip the next two, and I'm going to go to your evaluating so that we can get done with these. I will stay on, if you would like me to do 5 or 6 on these notes, I will stay on Zoom and do that with you, but I don't want to waste too much time. And then these are really, I don't know why he's on the Zoom. Adam, this is not your Zoom time. And I don't think they were the same link, but apparently they are. Okay, so if we're evaluating functions, what we're looking at is this number compared to these two functions, okay, or these two domain restrictions. Which one does 3 fall in? Is 3 less than -2, or is 3 greater than or equal to -2? Which one is it? The first one or the second one? The second one. So what we do is write our function down. Our function is -4. If there's an x to plug into, then we plug 3 in for the x. If not, this is as good as it gets, okay? So this is a weird one, but the rest are all basically the same, okay? So look at -4. Does -4 less than -2, or is it greater than or equal to -2? It's less than. So we use the first function. The first function is x plus 5. When we have an x, we want to plug that -4 in. What is 5 plus -4? 1. So figure out the function, plug in. If the function is a singular number, there's nothing you can do. You just write it down, okay? You will have that on your test, that singular number, okay? -2. Is -2 less than -2 or greater than or equal to -2? Is what? It's equal to. So we're going to use this function -4. There's nothing to plug into, so we're done. That's your answer. The rest of them we're going to plug in every time because there's a function every time. All right. So let's look at number 2. Is -2 less than 1 or greater than or equal to? It is less than 1. So we're going to use the function, the first function. And then we're going to plug our -2 in. So 2 times -2 plus 1. -4 plus 1 is -3. That's all you do. So evaluating is the easy part. All right, the next one. Is 6 less than 1 or greater than or equal to 1? So we use another function, 2x plus 3, the second one. And then we plug in 6. -2 times 6 plus 3. -2 times 6 is -12. plus 3 is -9. Does 1 fall in the first one or the second function? The second function, which is -2x plus 3. And then we plug in 1, so -2 times 1 plus 3 is -2 plus 3 or 1. I want to drop down to number 4, so that we can look at 3 of them. So number 3 is exactly the same as the top 2. There's nothing different about it. Pick the first one or the second one. So then this one, does -1 less than or equal to -2? Less than -2, but, greater than -2, but less than or equal to 4. So between -2 and 4, or is it greater than 4? The second one. So we plug in the second one and then plug in -1. So again, it's the same thing. You just have 3 functions instead. Okay, sorry, that's not second period person. All right, look at the next one, -4. Is it less than -2, between -2 and 4, or greater than 4? It's the first one. It's less than -2, so x minus 1. You're going to plug in -4 minus 1 is -5. And then where does 5 fall? The first one, the second one, or the third one? Is it less than or equal to -2, between -2 and 4, or greater than 4? The third one. So we're going to write that down, and then we're going to plug in 5. -3 times 5 is -15, plus 8 is -7. Number 5 and number 6 are exactly the same way. You're just plugging in. So what I'm going to do is I'm going to stop sharing and stop recording.